Hey guys, this video is going to be a bit longer. It'll be all right. But this one's about ions and average atomic mass. Just make sure y'all have your periodic table handy or pulled up, okay? So, ions are atoms that lose or gain electrons to form charged particles. And these were in your POGIL that we did, that activity that we did, the nuclear model. Okay, it showed ions. So remember, that was when the protons and electrons were different for the atom. Okay, positive ions are called cation ions. And the way to remember this is cat has a T in it for plus. Okay, negative ions are called anions. And normally negative or opposite is the an prefix in English. So that's how you can remember that. Also, sometimes people remember cats are good and ants are bad. So if you want to do that way, that's fine too. The charge is shown in the upper right corner, which again, we did see in that nuclear model activity that we did. And you can see them here. Notice the charge number is written first and then the plus or minus. Okay, so when we're losing electrons, we give them away and we become positively charged, or cations. This is something good to have in your notes, the ion charge. To find the charge, you do protons minus electrons. Okay, that's a great way to find charge. You will need to find charge for this test. Okay, when we gain electrons, or they go into the arrow because they're reactants, they become negatively charged and they become anions. You still find the charge the same way, protons minus electrons. All right, so magnesium with 10 electrons. So Mg, so I'm going to write it over here. A has 12 protons minus 10 electrons is a plus 2 charge. B, sulfur starts out with 16 protons. I'm going to write P plus. Minus 18 electrons is negative 2 charge. And iron, I don't know that one off the top of my head. I think it's 20. Oh, I was thinking it's 25. It's 26. So it's got 26 protons. Minus 23 electrons is a 3 plus charge. Okay, so it's just protons minus electrons give you charge. So let's do some more. Nickel. Nickel has 28 protons. Minus 26 electrons is 2 plus charge. Bromine, that's nickel, is 35 protons plus minus 36 electrons equal negative 1 charge. And then phosphorus has 15 protons minus 18 electrons equals a 3 minus charge. Okay, so determine the number of protons and electrons in a calcium 2 plus ion. Let's go ahead and, well, they didn't tell us the mass number, so we can't do, oh, we haven't even gotten to that yet. We'll get to that in a little bit. Okay, so calcium we know has 20 protons. If it normally has 20, so electrons are equal to charge. Let's do this. So protons minus charge. So then our electrons are equal to okay, we're just going to leave it there. So I've got a 2 plus charge. I've got 20 protons minus X. Okay. So X must be 18 to equal 2. So I've got 18 electrons. All right, let's do sulfur. So sulfur 2 minus, so I've got 16 protons. If I've got 2 minus, that means I have 2 more electrons, so I've got 18 electrons. Okay, Just remember those valence electrons are denoted by the A's and the B's at the top of each column. And the key to predicting charge is making sure they have an element arrangement similar to the noble gases, which is that last column. And remember, they have 8 valence electrons. So the goal of each element when it forms an ion is to be similar to the valence electron, or sorry, to the noble gas that's closest to it. Okay, so like lithium could lose 1 electron and look like helium. But fluorine could gain 1 and look like neon. Okay, so that's their goal. They're just trying to look like their closest noble gas. Something else to note, they don't have to have the same number of neutrons. This has nothing to do with ions. Okay, these are now isotopes. So the definition of the isotope is the same number of protons, but a different number of neutrons. Okay, we haven't talked about neutrons yet. But, oh, this should have been before. But based on their position on the periodic table, what ions do barium and iodine form? So barium is 2, so it's an alkaline earth metal. It should have a 2+ charge. Iodine is a halogen. It should have a negative charge because that's the way to get them to their closest noble gas on the periodic table. Potassium will be a +1 charge. Selenium will be a 2- charge because, again, closest elements on the periodic table that are noble gases to them. Okay, back to isotopes. So there are different isotopes. Neon is a great example. Neon has 3 different common isotopes, and they're neon 20, neon 21, and neon 22. Okay, so all neons have 10 protons, which is what your nuclear model activity was about. But notice they have different numbers of neutrons. Those are what isotopes are. So they're the same element, different number of neutrons. So this is called isotope symbol notation. It is very important. We will use it, and it's common, and you need to know them. Okay? So remember the atomic number, those are the protons. The chemical symbol just comes from the periodic table, and then mass number are the number of protons plus neutrons. All right, so the mass number is the sum of the protons and the neutrons. And the number of neutrons is the difference between mass number and atomic number. Okay, sometimes isotopes are written like this, where they write the chemical name or symbol, and then they write the mass number, which is why we call them neon 20, neon 21, and neon 22, because that differentiates between the different isotopes. Okay, so we're looking for a carbon isotope, so we know that carbon has 6 protons, 7 neutrons. The mass number would be 13. So I'm going to write A, Z, and then there's our symbol for carbon. Okay, atomic number, mass number, and symbol for chlorine. So chlorine is element 17. If it has 18 neutrons, I just add those together to get my mass number. All right, this one's a little different. I do want to do electrons in this one as well, even though it only asks for protons and neutrons. So remember, protons are that bottom number, that's 24. Neutrons, oh, my computer is validating its operating system. So we would just do 52 minus 24, which is 28. Okay, and then remember, if no electron charge is shown, it's the same as the protons. All right, let's do the next one. Potassium would have 19 protons, 20 neutrons, and 19 electrons if asked. Okay, you will be filling out a table that has protons, neutrons, electrons, mass number, things like that. It's going to be very important you understand this because it's going to be on your test, both the Chapter 4 test and the 2 through 4 test. Okay, as far as the average atomic mass goes, that's a little different. And that's the mass that's actually listed on the periodic table. Okay, to find that, they're going to give you percentages of the different isotopes. Okay, they're also going to give you masses. If they do not give you masses in AMU, they'll give you the mass like this, 35 and 37. But they will probably give it to you in AMU. Okay. To find it, you do the fraction of the isotope, which is just the percentage divided by 100 times the mass. And you do that for each isotope. And then you add them all because it's a sum. So let's do this one. I've got a mass of gallium-69 with a percent of 60.11. And then I've got gallium-71 with a percent of 39.89. Okay, so I'm going to do mass times percent. So I've got 68.9256 times, and remember I want this in decimal form, so I'm going to do 0.6011 plus 70.9247 times 0.3989. Okay, remember that's the percentage in decimal form. If you enter it into your calculator just like this, it's going to come out right. I get 69.72, and for now our unit's going to be AMU. It could be grams, but right now we're going to focus on that AMU. Okay, this is when you go check on the periodic table and make sure it's close. If it's not close, then something's probably wrong. All right, as far as radioactivity, some isotopes are radioactive, so they're not stable. That's what radioactive means. And when that happens, they could emit radiation, and that's how they're deemed as radioactive. Okay, so hopefully you know that nuclear radiation can be harmful to humans and other organisms. So there are some isotopes like lead-185. They emit significant amounts of radiation, but only for a very short time. There's also ones like plutonium-239 that are radioactive for really long periods of time, so thousands, millions, or even billions of years. So they're not always harmful to us. Many have beneficial uses, like, I don't know if any of you have had any medical procedures, maybe your parents have, where they had to either ingest or they were injected with some kind of radioactive dye. And then when they're put under the machine, and again, it depends on what kind of machine, but then it's easy to see what's happening in their internal organs. Okay, so in 2015, I had my gallbladder out, and I had to take a barium isotope that was radioactive. And basically what happens was when it was going through my gallbladder, it lit up and it was able to show them what was wrong. And that's it. This is just an overview. So if y'all have questions, let me know. Y'all have a great day.